I got a question for you guys. How many of you are getting a part like this and you're welding when you should be bending? Oh, just in time. Got my parts? Sweet. Let's go do some bend testing.
Right on the cut.
It looks good, man.
Shot.
Alrighty here.
Which one was that?
Oh, I'm gonna program it from scratch just to show them how to do it.
Gotcha.
So, but just so you can see, you can program a bunch of different products in here, and then if you need to go back and bend it, you don't have to reprogram every time. Just go in here, select what you need. Working on raised garden beds, and then you can go into the file, but we're not doing that. We are going to program a new one. All right, so we're gonna call this our YouTube test piece here. Enter, we don't need a description. All right, thickness, this is really important. This is hot rolled steel, so the thickness kind of changes a little bit between batches. So I wanna go over here, figure out our exact thickness. Looks like we are 0.2, actually pretty bang on. That's some good steel today. So we're gonna call that 0.25. Enter, material steel, bending length is gonna be 8 inches. And I'll show you up here, this is what we're gonna form up as this box. Printed out my nice little drawing, and we're gonna copy that here in just a second. So our dimensions, we want it to be outer dimensions. Radius used calculated. Let's let the controller do the math here. So we're gonna start here, 8 inch. And then we've got a leg up, and then our leg is 2 inches long. So 2 inches there, 2 inches there, and then we're going to go to tool setup. So here we've got our light goose. That's what we've got. This goose punch, it's for lighter tonnage, so we call it the light goose. We have a heavy goose too, but the we've got a heavy goose too, but it doesn't go as deep for like double flanges, but this has plenty of tonnage for what we're doing, just at 8 inches long. So we're gonna select that. Our lower die, right now the guys are bending some really thin sheet metal, so they've got our little tiny lower dies here. We're gonna switch that out. We need to be 1.5 times our material thickness. So for a 1/4 inch, 5 times our material thickness, so 1/4 inch, that's gonna be 1.25 inch minimum die opening. So that one's too small, 2.36. There's our lower die. And then we're gonna go over here to bend sequence. We can have it pick the tooling for us, but I already like the tooling that I've got, so I'm just gonna have it pick a bend sequence. Then we can go ahead and preview it. Make sure there's no collisions here. Product's complete. Unbend. Sweet. So it gave us a little warning. It's saying that our computed force is over our punch resistance we have programmed. So we could swap this out to the heavy punch. It's kind of giving you a little bit of a guide so you don't use the wrong tooling. I've already done this kind of bend with this kind of material and this tooling, so I'm pretty confident it's gonna work. So from here, we're gonna go to program, and we are good to go. All of our speed. Now we're gonna head into auto. Oh, we gotta start the machine. Turn our pump on. Hear the pump wind up. And everything's gonna move where we told it to go. And now we gotta swap out our bottom die here. So I like to do these with a tooling holder, and then we can segment all of the punches and dies into 1 meter sections about 3 feet long, and makes it a lot easier to unload and load this stuff. And then I'm also gonna turn the pump off. Just make sure it's safe while I'm in here in the jaws. The pump's off. Valves are closed. Looks like the girls left me a little present. Here's that tooling holder I was talking about. This thing's full length, but pretty manageable to move this around, where a lot of these lower dies and stuff get really heavy. Then we have our lower tooling holder right here. It's gonna hold this sucker dog we got going on. There we go. Gonna lower our support arm down. That should be pretty good. Now we need to load the right set of punches up here. So I'm gonna slide this out of the way over here. Slide this one down over here. I'll show you this. We got quick change tooling. So you push that button, slides in and out, slides in there, then you can lock it in place. So it makes it real easy to move this stuff around. We're gonna need one of those. Whoop. They will pop out. One of those. Let's see here, and probably one more little section. Bet this one that fell down on the ground. We use padded horse mat down here in case your tooling does fall, doesn't get dinged up. Lock that in place. And then our fingers are a little too far over this way, so let's get them pushed over. All right, so over here to tool setup. We're gonna tell it that it's only 8 inches long worth of tooling we've got there. And then we're gonna slide this, I think it's about right there. So we go over to auto. Oh, here, we gotta save this. Go to bend sequence, program, auto, save. And we hit this green button right here. The fingers slide over. And looks like we're nice and lined up. Then let's check that sucker for 90. It looks like it's a few degrees off right now. So let's see if we can see that. 90. Here, we'll get over here on the edge. 93 degrees, no big deal. So there's 2 bends in this program. We're gonna do a correction of 3 degrees and an automatically updated correction to 3 degrees. All right, guys, we got our bend tolerance dialed in here, and let's go bend the rest of this part. And then if you notice over here on the screen, it's showing us what the next bend is. Beautiful, nice, ready to weld corners. And we look back at our drawing here, we're looking for 2-inch legs, 8-inch outside to outside. Got 90 right there. Got our 90 right there. And we got 90.12 right there. It's dancing around. Just a hair under 8 inches there. And then we got 8-inch right on the money right there. This is what I'm gonna call our soft launch. We started with this machine 2 years ago, and we've been running it through the paces in our shop, running production on it every single day. This is how we roll out equipment. We buy it first, we test it here in the shop. Anything we find wrong with it or that we can improve on, we send the design back to the factory, have them make the changes, and that's when we start selling the machines to you guys. So these are proven machines. This is our second machine that we've gone through. We had a 30-ton, 5-foot brake that was really cheap, and I was hoping it was gonna be great, but it was an absolute piece of garbage. So we retired that machine, brought this one in. This is our second generation, and now we've gone ahead and made even more improvements, and the third generation is what we're actually offering for sale on our website. So we have a full line of press brakes, all the way from little mini press brakes we call desktop machines that run on single phase power, all the way up to 400 tons, 16-foot long brakes, 8+1 axis. Real quick intro here, this is our 6-axis machine, which means we've got our Y1, Y2, the thing can go up and down, obviously. We got our X fingers back here with the relief flaps on them. So as you bend the part, it doesn't bind up. This can lift out of the way and drop back down for the next bend. There's 2 positions here. You can use this as a work support surface and use this as the back gauge, or you can use this with the back gauge right here and set all that up in the machine. These arms go side to side, in and out, and also up and down. So this is our 6-axis of control. And the +1 you see on the press brakes is the anti-crowning. This has a beam that goes across so that when this frame here can deform into a U shape while it's bending between the 2 pumps, and that'll make you have a canoed part where the middle of the part will be, let's say 92 or 93 degrees, and the ends over here will be 90. So it's really important on long bends. Older machines, you had to sit here and put some shim packs underneath your center die and kind of do a little bit of guesswork. With this machine, the crowning is really easy to handle in here. You select right there and pick a number, and that'll change the crowning automatically along the entire working surface of the bed here. We got some redundancy back here. There's double limit switches in case one goes down, the other one will pick up. So you guys don't have to call us and get something simple replaced like that. We've got our ball screw controls on both sides for the Z motion. And then there is, it's tough to see inside of here, but there's another set of ball screws back inside of here that controls the up and down. Makes it super easy for bump bending. If you're trying to get a radius and the back of that part is slowly getting higher and higher, the back gauge will follow it up and let you bend bump bent parts or pick up a recurve the top of a flange. And also really handy when you switch out your lower dies, because some of them are taller and shorter, so the fingers will automatically move up and down to the height of the die. As soon as you tell it which one you've got loaded, the fingers automatically move to the right height. So a lot of small little improvements along the way, but a lot of stuff that really impacts your shop. I hope that was helpful to you guys. I'll be adding the press brakes to the website in the next week here. You guys can check out pricing and everything there. We don't hide anything behind a quote wall or an email campaign. You guys can see the prices right on the website. I'm not trying to hide anything. And I don't want to be the high pressure sales guy that makes you contact me for a quote and then I'm going to bug you for months on end until you buy a machine or tell me to get the hell out of there. And let me know what you guys want to see next on press brakes. I've got a 5-foot, 50-ton machine coming in, and I've also got a 8-foot, 170-ton coming in for a customer down in Chattanooga. So I'll be able to do some little reviews of those. They're different axis of control, slightly different controllers on them. This is the Delem 66T. We're moving up to the Delem 69S on future machines in the 6+1 and 8+1 categories. The smaller machines with less axis of control, we're gonna do a Delem 53T. It's a more affordable controller. You really don't need all the features they have on the 66 or the 69 until you get the more axis of control. It's just a waste of money. So we're not gonna waste your money, and we're not gonna waste your time by trying to push something that you don't really need on the equipment to run a simple 2 or 4 axis machine.